Pleasure to have the opportunity to introduce two women who it has been my honor to work with for the last 18 months, particularly on publication of their new books, the Common Core Mathematics Companions, which now cover grades kindergarten through 8th. And these are some fantastic resources that I recommend you check out if you get a moment. But here to talk about division today with the adorable title, Life's Too Short for Long Division, we have my good friends Linda Gojak and Ruth Harbin-Miles. Linda is former director of the John Carroll University Center for Mathematics and Science Education. She has spent 28 years teaching elementary and middle school mathematics and 15 years working particularly with K-8 teachers. And she has also served as president of NCTM, NCSM, and the Ohio Council of Teachers of Mathematics. Ruth Harbin-Miles is a mathematics coach with special expertise in developing teachers' content knowledge and strategies for engaging students to achieve high standards in mathematics, and hence the author of all three of these books. She has served on the board of directors for NCTM and NCSM and both the Virginia Council of Teachers of Mathematics and the Kansas Association of Teachers of Mathematics. And I know they have prepared about 45 minutes of wonderful information for you today, much of which was based on the questions you sent in. So thank you in advance for your participation. And I will turn it over to Linda and Ruth.
Well, hello, everyone. I'm Ruth Harbin-Miles, and I, too, am so glad that you are joining us. Linda and I picked the topic of long division because for many elementary and many middle school students, it seems to be a very difficult topic. As we begin, I want you to reflect and think about your very own experience in learning division and in teaching division. You may want to type in your comments in the chat box all about your experiences. But let me ask you this. Do any of you remember elementary worksheets with numerous long division problems all on one page? Or do you remember rows and rows of problems all on one page? Do you remember learning procedural steps with memorization such as divide, multiply, subtract, check, and bring down? Without a doubt, there is a tendency in the United States for students to practice solving numerous long division problems in a single class period. The problem is that students can learn a procedure with lots of practice problems. They can get right answers with a total lack of understanding, and they may never be able to apply or use the skill. Recently, I asked my college students to study and to find out why division is really hard for so many students. And here's what they said. Division is difficult because you need to use subtraction, multiplication, and division operations. There are 3 operations in one problem and multi-steps to get to the final answer. It's a long process to get to that answer. Is that why they call it long division? Division is difficult because you have to know the multiplication and the division facts fluently. Another student found that you need to be able to use estimation for quotients. And we do know that estimation can be a very difficult concept for many of our students. But without a doubt, you also need place value understanding, and you really need to understand the inverse relationship between multiplication and division. Finally, my students discovered that division is difficult because you really should and need to understand the meaning of division. And speaking of understanding division, we have 5 goals for our session. First, we want to develop the meaning of division and its relationship to multiplication. It seems like sometimes we teach multiplication first and then division separately. But we know that it is important to combine multiplication and division just as soon as multiplication is taught so that students can see and understand the inverse relationship. Our second goal is that we want to build rigor by using models to build conceptual understanding, And we want to link that understanding to procedural skills and applications like word problems and real-world scenarios. We'd also like to connect division of whole numbers to dividing fractions and decimals. Also, we hope to relate the learning strategies in the effective teaching practices in NCTM's Principles to Action. Now, if you have not seen NCTM's publication, you can go to the NCTM website to download a free executive summary, or you can download the entire book electronically for just $3.95. We'd also like to incorporate, as our fifth goal, to incorporate the standards for mathematical practice. Let me go back to the effective teaching practices for just a moment. In thinking about these practices are a framework for strengthening and deepening the teaching and learning of mathematics. The pink arrows are the teaching practices that we hope to focus on today, and we hope that you will observe these during this webinar. We are also going to reference the 8 mathematical practices, and we assume that you are already familiar with these 8 practices. I kind of like to think of these as student practices. They describe the expertise that we should seek to develop in our students. In other words, it's what students should be doing as they are doing or using mathematics. And then we're going to try to highlight these as we talk about the topic of long division. And then, of course, as Erin said, you'll want to know that our ideas are in great detail in the Corwin publications, the Common Core Mathematics Companion Series, what they say, what they mean, and how to teach them. So if you're a 3rd grade teacher, if you looked in the 3rd through 5th grade book, you can get ideas specific to your grade level. Well, let's get started with our first goal, to develop the meaning. Now, to do this, we're going to begin with some word problems that you might give students to solve. So I want you to choose one of the 2 problems that are going to come up on the screen, and I want you to show how you would solve these problems. Draw a picture for one of the problems, and I want you to be thinking about what's going on in the problems. And I'm going to give you 30 seconds to pick one of the problems and draw a picture. I may not have given you adequate time, but for the first problem, Martin has 42 peanuts and M&Ms. He wants to give them to 6 of his friends. How many will each person get? Did your picture or your drawings look something like this slide? Did you draw 6 circles or 6 groups to represent Martin's 6 friends? So if you did, you were making sense of the problem with the drawing. The first problem is known as a partitioning or a stair-share problem. What's going on and what's happening is that 42 M&Ms are being equally shared with 6 friends. Now, when you're solving a problem, Linda, I have 2 questions for you to always ask your students. The first question is, what do you know? I know that there are 42 M&Ms, and Martin has to give them to 6 friends. So what do you know? The second question is, what do you want to find out? Well, I want to find out how many M&Ms each person gets. These 2 questions are the questions we want students to be asking themselves as they attempt to solve every word problem. And then think, I have 42 items in 6 groups. How many in a group? This is sense-making, or 42 divided by 6, or 42 shared equally or partitioned out for 6 friends. Think each friend will be getting 7 M&Ms. For the second problem, in the game Reno, each player gets 6 tokens. There are 42 tokens in the box. What's the greatest number of people who can play at one time? Did your drawing look something like what you see on the screen? This type of problem is known as a measurement or a repeated subtraction division problem. Again, the 2 questions to ask are, what do you know? And of course, you want the students to be asking that same question. Well, I know that there are 42 tokens and each player is going to get 6. What do you want to find out? Well, I want to find out what's the greatest number of people who can play at one time. So how many groups of 6 tokens am I going to make out of 42 tokens? Well, as you solve it, 7 is the greatest number of people who can play at one time. The chart on the next slide is a summary of the 2 questions, what do I know and what do I want to find out? The chart can be handy to post in the classroom after students are familiar with the 2 questions. To understand division, you truthfully have to understand multiplication. In the next example, 4 times 6, what does the number 4 represent and what does the number 6 represent? Well, the number 4 represents 4 groups. The number 6 represents the number of items. 4 groups of 6 is 24. Using the number line is another math practice that's using appropriate tools to represent a model. Now, to summarize, in multiplication, we know the number of groups and the number of items on the next slide in each group. And we're looking for the total number of items. So 4 groups of 6 items is 24. That's multiplication. But in division, we know the total number of items and we know the number of groups, that is looking for the number in a group. We call that partitioning. Or we know the number of items in each group, which is 6, and we're looking for the number of groups, which is repeated subtraction. The key to division is when students can ask themselves the right questions, and if they do, they can work their way through any division problem, and they can estimate a reasonable quotient in a long division problem. Moving along, when you consider the problem 32 divided by 8, you have to personally ask the question, how many groups of 8 can I make for 32? Well, can I make 1 group? Yeah, 1 group is 8. Can I make 2 groups of 8? Yeah, 2 groups of 8 is 16. What about 3 groups? 3 groups of 8 is 24, and 4 groups of 8 would be 32. And I personally like to visualize this on a number line like you previously saw. In asking the right questions again, the second problem is a division problem with a remainder. And the kids should hear that voice and say, how many groups of 8 can I make for 38? Again, 1 group of 8 is 8, 2 groups, and so on. So finally, they'll be asking, how about 5 groups? Can I make 5 groups of 8? No, that's too many. So I'm going to have to make 4 groups of 8 and have 6 remaining. Let's consider place value for a moment. Instead of a single-digit divisor, we're going to now have a 2-digit one. So the first problem is 350 divided by 10. Again, those questions that kids need to ask, how many groups of 10 are there in 350? Can you make 10 groups of 10? Yeah, 10 groups of 10 is 100. Can you make 20? Yeah, that's going to be 200. Can you make 30? Yeah, that'll be 300. How about 40? Oh, 40's too much. So you know the quotient's going to have to be somewhere between 30, but it's going to be less than 40. So you're getting students simply to ask the questions, how many groups of? Let's go on to an estimation example on the next slide. When you see the problem, 568 divided by 27, I have to tell you, I was actually in a 5th grade classroom where I was coaching, and the teacher said to me, I just want to pull my hair out when I have to teach problems like this. Life really is too short for long division. So I asked the teacher to think about making it an easier problem using compatible numbers. That is a difficult problem for many kids. So instead of the dividend being 568, make it an easier problem to estimate. So, you know, I'm thinking that 568, the compatible number for 568, which is an estimation strategy, is 600. It's also a rounding strategy. I'm going to consider the problem to be now 600 divided by 27 is not an easy number to work with. I'm going to make it a compatible number of 30. So my estimation problem becomes 600 divided by 30. Now I can ask how many groups of 30 can make 600. Take a second and answer the next question, the next problem, 1,256 divided by 41. Using estimation, what are the compatible or easier numbers that you would use to solve this problem or to find an estimate for the quotient? For me, I used 1,200 divided by 40. I thought that would be an easy start to get an estimation. All right, well, our next problem on the next slide is going to promote thinking and reasoning, and of course, this is one of NCTM's effective teaching practices. And thinking and reasoning is also one of the student mathematical practices. To solve this problem, we're going to need to be thinking about what happens with the remainder. And of course, this is a real-life type of problem as well. So here's the problem. The 5th grade is planning their class party. There are 28 students in the class. If hamburgers come 12 in a package, how many packages do they need to buy so that each student gets one burger? The questions, are they popping into your mind? What do I know? Well, I know there are 28 students and 12 hamburgers in one package. What do I want to find out? I want to find out how many packages to buy. To solve the problem, ask, well, how many groups of 12 are there in 28? Well, you know that the answer is 2, remainder 4, but I can't buy 2 packages with a remainder of 4. So in this problem, the students must round up and drop the remainder, so 3 packages will be the correct answer. The next problem you're going to see is a good problem because it's also going to promote thinking and reasoning. You know, to solve problems like this, I personally believe that students must have multiple practices with varied problems to make sense of division and, of course, what the answer will be. Julie's sharing a bag of peanut M&Ms with her friends. There are 67 pieces of candy in the bag, and Julie has 6 friends with whom to share. Julie's little sister gets whatever's left. How many M&Ms will Julie's sister get? Okay, what's the question? Can I hear you asking, what do I know? I know that Julie has 67 M&Ms, and she's sharing them with 6 of her friends. So that means that 7 people will need to share the M&Ms. Julie and her 6 friends, that's 7 people are going to have to share the M&Ms. Therefore, students need lots of varied problems like this. What do I need to find out? I want to find out how many M&Ms Julie's sister will get? She gets the leftovers after the friends and Julie get all the M&Ms. So 67 divided by 7, how many groups of 7 are there in 67? Well, 9. But there's a remainder, and the remainder happens to be the answer. Julie's sister is going to get 4 M&Ms. I have one more problem to share before Linda takes over. The last problem is Marta has $5.85. She wants to buy some folders for her mathematics projects. Folders cost 30 cents each. How many can she buy? The question, what do I know? Marta has $5.85, and she's buying folders for 30 cents each. So what do I want to find out? How many folders can she buy? How many groups of 30 are in 585 cents? In this problem, when you divide, you keep the answer, but you're going to drop the remainder. And again, I personally believe, and I think Linda probably would say yes too, that students need varied practice and lots of distributed practice with different types of division problems. Hopefully, we've developed the meaning of division and its relationship to multiplication, and we've linked the conceptual understanding to some word problem applications. Linda's next going to connect division of whole numbers to dividing fractions and decimals. Linda? Linda, we can't hear you.
Linda, it seems people cannot hear you. Can you unmute yourself?
Hello?
Linda?
Yeah. Can you hear me?
We can hear you now. It's your turn. Division of fractions.
Okay. I'm sorry. I don't know what was happening there. And I'm not sure if I'm talking to through my computer or my phone. Anyway, what I want to do is continue with some examples around division of fractions.
Hey, Linda, I think the problem is that you're too far away from the phone. You might need to use the headset because I think the speakerphone might be too far away.
We're building procedural fluency from conceptual understanding. So before we were talking about groups and how many items are in a group. And so what I'd like you to do is think about the problem 3 1/2 divided by 1/2.
Hey, Linda?
And this is your first experience.
Linda?
This is your first, is that better? Some people are saying they still can't hear me.
Hey, Linda?
Hello?
Linda, I think you're a little far away from the phone. Can you use the,
no, I'm right
the
next
headset?
to the phone.
It seems like you're fading in and out. Do you know if you could just use the headset or do you have like a, take it off speaker?
I'm not on speaker, and I think right now I may be talking through my computer because it doesn't seem that my phone is working.
Let me double check.
This was all working
says you're
fine.
called in.
Hello?
Yeah, it seems to be working now. I think you just have to talk into the phone.
Okay, well, that's what I've been doing, but I'll try to talk louder. That's usually not a problem for me. All right, so anyway, let's try again. What I'd like you to do is think about a word problem for this. And thanks for your patience on this. So somebody commented earlier that I was doing most of the chatting, and I apologize for that, but I didn't see many comments. So I'm really looking for someone to write a word problem for 3½ divided by 1/2, a problem that makes sense. I was asked to do this in a graduate class many years ago, and even though I knew the rule to invert and multiply, I had no idea how to write a problem to go with it. So anybody have a problem? Oh, I think I see one there. You have 3½ feet of ribbon. Oh, now I got lots of comments. Excellent. You have 3½ feet of ribbon, and you need to cut it into 1/2 foot pieces. How many pieces can you make? That's exactly what you ought to be starting with your students with, so they can actually get a picture of what is going on. So let's talk about that. I have 3½ feet of ribbon. Oh, a potato is 1/2 foot long. How many potatoes would it take to create a line 3½ feet long? Wonderful problems. Thanks, guys. So if we, now I'm trying to work the computer and talk. So if you take a look at a model of this, perhaps my 3½ should have been linear, or maybe those are my 3½ pizzas. How many people can I feed if each person gets 1/2 a pizza? So having kids literally break that into 1/2 pieces, divide up the 3½ into pieces that are 1/2 each, is going to help them to understand what's going on before they even think about whether or not that's division. So letting students model. We could do the same thing. So I started with one that was pretty obvious. In the next example, the fractions are a little bit more difficult. 7/8 divided by 1/8. So I want you to think about the questions that Ruth was modeling earlier. What I want kids to think about when they see this is not ours, is not to reason why, just invert and multiply. I really want kids to think about how many groups of 1/8 can I make out of 7/8. That's what they have been doing with whole numbers. And I want them to make that transition that division doesn't change when they get to fractions. We're not going to give them some mysterious rule that they now apply. Division is still division, even though I'm working with fractions. So if I were to put this into a context, I might say I have 7/8 of a pan of brownies, and each person is going to get 1/8 of the pan of brownies. How many people will get a brownie? So I can actually see that I can make 7 brownies. I can cut 7 brownies out of that 7/8 of a pan. So I'm asking myself, how many 1/8 are there in 7/8? I'll tell you, when I taught 6th grade, this was in the 6th grade curriculum. It's in many countries now, it's been moved down to 5th grade, which makes me a little bit nervous because I taught 5th grade for many years. I'm convinced that some of my 5th graders weren't even sure what a fraction was. But they would hear me over and over and over again say, how many groups of 1/8 can I make out of 7/8? How many groups of this can I make out of that? So let's talk about, okay, so Devin just said, couldn't students explore the idea of dividing across in fractions as a strategy? I think that's really a good question, and I want you to think about that. I'm assuming that Devin means I can divide the numerators and divide the denominators. So hang on just one second, because I want to come back and revisit that idea. Here's another one. Notice that in the first, well, I'm not going to answer that. I'm answering my own question here. I do that a lot. Got to be careful. How does this one differ from the previous 2 examples? And the previous 2 examples were 3½ divided by 1/2. How many 1/2s can I get out of 3½? And 7/8 divided by 1/8. How many 1/8s can I get out of 7/8? So I think some of you may have noticed that we were dividing unit fractions. There we go. Yeah, a lot of you are putting that in now. So this time we're not dividing by unit fraction. We're dividing by 2/5. And so the question doesn't change, though. I'm asking myself, how many 2/5 can I make out of 4/5? So you have to excuse my little chicken scratch here, but I'm seeing that I want to make groups of 2/5. I have 4/5, and kids can actually circle or color in. The red represents one group of 2/5, and the blue represents another group of 2/5. So the answer to that is 2. If we go back to Devin's theory, Devin's conjecture, what's happening again? It looks like we can divide the numerators. 4 divided by 2 is 2. 5 divided by 5 is 1. But I want you to stop and think for just a minute. What is the numerator telling us, and what is the denominator really telling us? So the year that we did this, I decided we were no longer going to just learn to invert and multiply. Many of you may have seen kids come up with a lot of concoctions 2 weeks after you've taught them to invert and multiply, where they're inverting the wrong number, or I've seen kids that invert and still divide. And then I've even seen students, when we go back to do some practice on multiplication, they will invert one of those numbers and divide. So the rule is generally pretty useless, at least in the mind of a 5th or 6th grader. And I think they can get into multiplying by the reciprocal as they start to look at more advanced topics, even later in the 6th and 7th grade. So I noticed that somebody said that the numerator is telling you how many pieces, and they're exactly right. The numerator tells you how many of these pieces do I have, and the denominator is really describing the piece. So if you look at the 4/5 divided by 2/5, I really have 4 of these things called 5ths, and I want to put them into groups with 2 of these things called 5ths in each group. So because the numerator is really telling you the count, those are the numbers I'm actually dividing. The denominators are simply describing what the piece looks like. Okay, so let's move on to a different kind of an example. I'd like you to think about what this might look like. You're stuck in a traffic jam on the highway, and it's a 1/4 mile to the next exit. You determine that you are traveling at the rate of 3/4 mile per hour. How long do you think it's going to take you to get to the next exit? What is this problem asking? So let's go back to which number, the total distance we want to go is what? 1/4. And we're traveling at a rate of 3/4 mile per hour. Do you think it's going to take you an hour to get to the exit? Well, I know it's not going to take me an hour. It should take me less than an hour. So let's take a look at how we might model this example. So I'm really asking myself, how many 3/4 can I make out of 1/4? This is where the kids start to go a little bit crazy, but if they can draw a model. So you can see the blue line represents how far am I traveling in 1 hour? I'm traveling at 3/4, but I only need to go 1/4 of a mile. So I only need to go 1 out of the 3/4 miles it would take me to go, that I would go in an hour. So you can tell I'm even stumbling about this. I have to stop really hard and think about what this means. I'm going 1 out of the 3/4 I need to go, so I'm going 1/3. I will only need to travel 1/3 of an hour to go 1/4 of a mile. This is where units and what I'm talking about and what I'm measuring become really, really important. Okay, somebody asked a good question here. Doesn't this relate back to understanding that the unit, or in this case, 5ths, is just a number? You can think about it as a unit. I really think about 5ths as more of a description, because I think too often when kids see numbers or say number, we usually use number in terms of a count. And I think where this gets strange is I'm really saying I have 1 apple and I need 3 to fill the bag. I need 3 apples to fill a bag. What part of a bag do I have? So you could think about that as 1 divided by 3 for this exact same problem. And just mentioned, she always has her students write a final statement. It brings them back to what the problem is asking. You know, in graduate school, I had a professor who said kids should always label their answers. And I said, oh, good luck. I can barely get them to solve the problems, let alone label their answers. Well, you know what? Once I expected kids to label their answers, they did. And then I moved up in the world and actually expected them to write a sentence to answer the question. It brought them back to focus on what the question meant and maybe think about, is that a reasonable answer? So, and you know what? When I expected it, the kids did it. So let's go on to, here's your homework. I want you to think about, I'll collect papers tomorrow, I want you to think about that, what would you do if you had two different denominators? So we've moved from dividing by a unit fraction where it works really nice to dividing by a non-unit fraction, and then dividing two fractions where it doesn't work out quite so nice. And now we're working with dividing two fractions with unlike denominators. And again, I would work very hard to think about putting these in context. Give the kids a word problem to go along with it so they can actually draw a picture and model. And by the time I got to this, I really had my kids saying, how many groups of what can I make out of what? So they were, you know, when they would get stuck, I would say, well, what number is telling you the number of groups? And what number is telling you the total number that you have? It's back to that chart that Ruth had earlier in the presentation. So somebody said we'd have to make equivalent denominators. Absolutely. You're going to need to change this to 2 4/10. Whoops, jumped a little bit ahead here. 2 4/10 divided by 3/10. And if you change the 2 4/10 to an improper fraction, it's very easy because once I've got the denominators the same, again, I've made my unit the same size, so all I have to do is focus on the numerators. Easy for me to say, huh? This takes a lot of practice, a lot of practice. You really have to take your time to teach this concept meaningfully. But I will tell you that if you do it and kids can ask themselves the right question. Earlier somebody said, somebody said my kids can't solve problems with division. My kids, when we got to fractions, couldn't tell whether they multiplied or divided one. They could identify addition and subtraction, but they could not tell whether to multiply or divide. So there's some good chat going on, but I'm going to continue, and you guys go ahead and listen and read the chat, if you're able to do so. Someone mentioned earlier, why does the way that we currently or traditionally teach division of fractions, invert and multiply, how does that really help students, why does it work, and how does it help students to understand what's really going on? And I am not, it could be a whole lesson in itself why it works. I will tell you, I still remember my 5th grade teacher explaining why it worked, and it made sense to me why it worked, and I could still show you today why it works, but it would not help me to solve any problem because it would not tell me what's really going on when I divide. So if I came across a situation where I actually had to use it, just based on invert and multiply, I wouldn't know that I had to divide. Okay, so we're moving on here, and I hope we have some good questions coming up. I want to move on to division. And these next 2 slides come from a program that was around many years ago called the Lane County Mathematics Project. It was from Lane County, Oregon. And unfortunately, when I left that teaching job, I left the books behind. I've tried to buy them on Amazon used books. I found one of them for $200. It was just a wonderful math program, but I love this slide because it really now has kids, before they learn any rules at all about moving decimal points around, because that's what we tend to do, is teach them to just move the decimal point around, to really think about what a problem means. So I'd like you to choose one of these. You can choose whatever one you want. And I'd like you to, no calculating, no moving decimal points, no getting out the calculator. I'd like you to tell me what you know about the solution. So if you want to pick one of those, I'll give you a couple seconds to go ahead and type something in the box. Just let us know which one you're you're working on, what do you know about the answer to any one of those problems? Choose your problem of your choice. Okay, somebody chose number 2, and they said, I know the answer is going to be really close to 40 because 95 hundredths is close to 1. That's exactly the kind of thinking I want my kids to be doing. Exactly the kind. Boy, I'll tell you, Kaylee, if I had some chocolate, I'd throw one out to you right now. I am asking myself, how many groups that are almost 1 can I make out of 39 5/10? Oh, dark chocolate, you got it. I'm tossing it. Hope you can catch it. How about the first one? What's a good question to ask for the first one? Somebody said for number 3, the answer is going to be a little bit more than half of 436. I'm wondering why that's true. Am I taking half of 436? I'm really asking myself, how many groups? I'm going to use Ruth's method of thinking about 63rd hundredths as a half. I'm really asking myself, how many groups of a half can I make out of 436? How many groups that are about a half can I make out of 436? Can I make half of 436? How many halves are in 436? I want you to think about that a little bit. Number 1, how many nickels are in 16? How many nickels are in $16? You know, kids work really well with 2 contexts, food and money. How many nickels are in $16 is a great context for that. And kids realize why their answer is getting so big. That's a lot of nickels. And so they might say, well, there's 20 nickels in $1. There's 40 nickels in $2. Wow, that's a lot of nickels in 16. So they can start to realize what's actually going on. So nickels and dollars in an international school absolutely are going to be more difficult. But is there another context that you could put that in? I want to go back to number 3, though, because I really want somebody to give me about how many halves are going to be in 436. I want to go back and look at that notion of, am I taking half of 436? I'm actually going to be doubling it. Good. Some of you saw that I'm actually doubling it. This is where I'm starting to get into that notion of, even though I'm not teaching the kids a rule, that when I'm dividing by half, I'm beginning to see a pattern. It looks like I'm doubling. I wonder why that's happening. Okay? And then actually as kids do this, I'm watching the clock here. Actually as kids do this, they can hone in closer and closer. So if I go back to number 2, and I say, I know the answer is going to be really close to 40, then I can start to ask the kids, well, do you think it's going to be more than 40 or less than 40? Kids need to have, these are the kinds of estimating experiences we need to give kids before they actually start following rules about moving decimal points around. And Callie gets the final say on this particular slide, at least the final one that I can see. The final answer should be less than double because we're dividing by more than half. So our groups are a little bit more than half, so our answer is going to be a little less than double. Exactly right, because our groups are bigger. When you can get kids to have a conversation, this particular slide might take half of a math period. And by the way, I would put these up one at a time for the kids to discuss. I can't do this when I'm virtually manipulating slides over here. Okay, so I'm going to move on to the next one now. This time, this is a really hard one to do with adults, but this is a wonderful one to do with kids when they have learned no rules yet, because they're not tainted by rules that we learned somewhere along the way. This time, I tell the kids that I have this wonderful calculator. It's very interesting because I can put the division problem in. That's my dog barking in the background. She's been pretty good up until now. I can put the problems in and the decimal point shows up, but after I press the equal sign, the decimal point doesn't show up in my answer. So where do you think the decimal point is going to go? And again, before kids learn any rule, it starts to get them to think about the place value of the numbers they're dividing. And I have to giggle a little bit because sometimes when I'm working with teachers and I do this, they automatically want to go back to the rules of moving the decimal point. But kids won't do that if they don't already know the rule. And they start to focus in on what do the numbers mean, not what is the rule. And so in the first one, I'm asking about how many groups of 4 can I make out of 68? Well, you know, go back to Ruth's idea. I could think about 5 and 60 or 5 and 70. I could think about this as being 60 divided by 4. If I really think about the value of the numbers that I'm dividing, it helps me to figure out where the decimal point is going to go. So I want to leave these for you, and if you're a coach, share them with your coaches. If you're a classroom teacher that's teaching 5th or 6th grade, what I really want you to see is the connection between what we're doing with the decimals and fractions and the much earlier examples that Ruth was doing with trying to help kids make sense out of what's going on when they're dividing decimals, or excuse me, whole numbers. And I'm thinking to myself, at the beginning of 5th grade, kids would come in and I would wind up spending the first 2 or 3 months reviewing multiplication and long division. And then it dawned on me that, you know, part of the problem was kids really didn't understand what they were doing. And so this notion of really making sense out of what you're doing and trying to put it in problem context, having kids actually write some of the problems, they're not easy to write. I gotta tell you, dividing 2 fractions is not easy. It's not easy to write a sensible problem when you're doing that. I'm going to leave you with, I left you with some homework. Now I'm going to leave you with a gift, and then we're going to take a look at some of your questions. There is a wonderful video. There are several wonderful videos. One is on YouTube about Ma and Pa Kettle doing division. My favorite is this Abbott Costello video. It's a short snippet from the Abbott and Costello movie In the Navy. It's an old movie, but every time I watch this, I giggle. And if you're teaching 6th grade, maybe even 5th grade, you might want to share this video. I have the URL that I was able to find it. I could not find this one on YouTube. You might want to share it with 5th or 6th graders to let them see what they think about their conversation about 28 divided by 7. I don't know that I would show it to 3rd or 4th graders. I think they might learn some bad habits. So at this point, the last idea that I want to leave you with is that I really believe that math should make sense, and everything we do in math should make sense, and that includes division. So if we're teaching division rotely as a bunch of rules, divide, multiply, subtract, bring down, no wonder kids are struggling with it. We have to take our time, and we really have to put it in context where kids can struggle productively to make sense out of what they're doing. And here's just a little selfless, shameless self-promotion. And I'm going to open the chat box back up and wonder, I think we have a few minutes for any questions now. Ruth,
yes,
are you still with us?
We have a few questions. From Melissa Bird, she's asking, it seems that 3rd graders are often asked to put the answer in simplest form. Is that really counterintuitive? It seems as if that would lead them to just get an answer rather than think about why the answer makes sense.
I'll take this one and then Ruth can pipe in. This is Linda. You know, it's very interesting you asked that, Melissa. I don't know where you're from, but Common Core does not require kids to put answers in the simplest form. No place in the Common Core will you find kids have to put their final answer in simplest form. That doesn't mean I don't want kids to be able to look at 12/24 and not realize that that's a half, but it means that we shouldn't, I've heard the authors of the Common Core talk several times, we shouldn't be having to spend a lot of time on driving kids crazy about putting answers in the simplest form. And I think what you're saying is a wonderful reason why that's so important. Ruth?
Linda, I agree with what you said. I do not believe that third grade should be putting the fractions in simplest form. For so many kids, it's a procedural thing rather than an understanding piece, so I agree.
Okay, we have one other question from John. He's been needing help with this math question. He says it could be solved with fractional division, but he could not think of how it would make sense to his students. The problem is Susie used 3/4 of a gallon of paint to paint 2/5 of a fence. How much paint does it take Susie to paint the whole fence? And he says the answer,
I'm saying wow.
Yeah. The answer is 15/8 of a gallon, or 1 7/8 of a gallon can be found by 3/4 divided by 2/5, but he doesn't understand why that works.
I need to draw a picture. Time out, I need to draw a picture. Ruth, you want to try it, or you?
No, I would be doing this.
Go ahead.
I would need to draw a picture too for the elementary level. But one of the things I want to say is sometimes when we're giving problems and providing problems to kids that they're not part of their background of experience, and the problems are kind of contrived and not really useful, and this is one of those problems that I'm not sure. What grade level is this for?
I don't see that. I'm actually drawing a picture. Oh, okay, John says 6th grade. I'm actually drawing a picture, and what I'm getting is if I drew 2/5 of the fence and said that was 3/4, and then I drew another 2/5 of the fence and said that was 3/4, and then I drew the last 1/5 of the fence would be half of 3/4. That's the way I would put it together. Now, I'm still trying to figure out in my own mind, is that a division problem, or and I'm thinking as I'm putting all those pieces together, which also actually brings me to another thought, and that is if kids can reason through how to solve that problem, if they can draw a picture and reason through how to solve that problem, I don't care whether they multiply, divide, or what they do, as long as their work makes sense. So I'm actually, in drawing the picture, starting to see why it's division, but I'm not sure I could still explain it. 3/4 divided by 2/5, but I can draw a picture of it. And so I don't know if that helps or not, but I drew each 2/5, and then I drew the last 1/5 and was able to, Terry says it's more of a proportional reasoning problem. I think it really is more of a proportional reason. And I don't know that there's any lessons to make sense out of invert and multiply, John. I'm sorry, that's just a really tough one for me. I also said that somebody mentioned Bridges math problems. I don't get them most of the time. You know, it takes I probably learned this way to divide when I was in graduate school, and I'm not going to tell you how long it was. It took me a long time of asking myself mental questions as I'm doing this, because I'm really struggling to make sense out of this division of fraction stuff. And sometimes it's really hard for me to make sense, and I will be honest. Sometimes I go back and cheat and I invert multiply just to check myself. But it really helps me when I'm trying to figure out what the heck do I do when I solve a problem. And so I think the words I have for you are, you have to practice and you have to become very disciplined in asking your kids questions and modeling the kind of questions you want them to ask themselves. Ruth did a really nice job with that, with the whole number examples. Ruth, any final words from you?
No, I was just thinking that I read a weekly reader survey several years ago about, at the elementary level, what students' most favorite topic and subject was. And most of the kids said math, all the way up until about 3rd or 4th grade. And I got to thinking, I think it's because they stopped liking math and hating it because of the long division. And so our task and our job and our goal is to try to help kids make sense and ask those good questions so that they can, in turn, be asking the questions as they solve and work with word problems. Make sense?
And I know that a lot of times our books don't do the best job in the world with that. It doesn't mean throw away your textbook. It certainly doesn't mean, you know, if you Google division problems, you can find all kind of stuff. You can find pages and pages of worksheets. I think what we have to do is really struggle to take those lessons and work hard and maybe work with the textbook publishers as well to start breaking those apart and taking the time it really takes to make sense out of doing this kind of work. And it takes a lot of practice on our parts because, quite frankly, most of us didn't learn how to do it this way. I kept saying, "Where have you been all my life?" when I first learned how to do this.
I think we have time for a couple more questions. Valencia Dublin asks, what strategy would you say is most important when introducing long division to third graders?
This is Ruth, and I think third graders still need to start with a hands-on approach with manipulative models as they're dividing before they even get into drawing pictures. That's me. So that's where I would start, and I would also use real-world problems that make sense to them versus some of the contrived problems that are difficult to understand.
And I agree 100% with Ruth. I would say that you need to give them lots of practice with easier numbers before you start getting into dividing by like a non-fact 2 or 3 digit number by a single digit number. So they need to have lots of practice, again, so that when they're modeling, they know what questions they're asking themselves. And I would still use place value materials when they're starting to divide by 10 and multiple of 10 so they can start to see the patterns of what's going on. Because if they don't know how to divide by 10s and multiples of 10, they're going to really struggle with dividing by a 2-digit number. And I think you have to go very slowly and make sure that the kids are comfortable with kind of each layer of that. And I don't think they start dividing by 2-digit numbers yet in 3rd grade. I think that starts in 4th grade.
And one piece of advice that I would have is to distribute the practice over time, because it's such a difficult concept for many kids. Again, just doing a sheet or a page of long division problems just really hurts a lot of our kids. They're just so frustrated with it. But doing that distributed problem of the day with a long division problem over time.
I think that's all oh, we have one more question. How about using the long 7 method of repeated subtraction?
I'll try to handle that. Repeated subtraction can be kind of cumbersome. So I'm thinking when you're thinking the long 7 method, that might be partial products. So kids might start with repeated subtraction, which is one of the models Ruth talked about. And, you know, you can keep repeating that number, but you want to move toward kids becoming more efficient so that instead of subtracting 1 at a time, they start to, again, subtract, you know, can I make 5 groups of 8? How many would that use up? And you know, they can use the partial, did I say partial products? I meant partial quotients down the side, and then working toward, and as Ruth said, over time, working toward, can I do that in fewer steps? I actually like partial quotients. I don't like them when kids are subtracting 1 group at a time. But for kids that really struggle, that's where you got to start. And then asking the question, well, do you think you could make 2 groups? How about 5 groups? How many would that take? And getting kids to start, again, asking those questions in their own heads. But I think that partial quotients is a nice place to start, and that in some respects is the repeated subtraction model.
Great. It looks like we don't have any more time for questions. I just want to thank you all for being here. If you have any final words, you could email us, and we will try to get back to you.
And don't forget, they will be sending out, I don't know if they'll be sending out the actual Oh, my dog was so good up until now. They will be sending out the, I don't know if they'll send out the PowerPoint or a link to the PowerPoint, but you will be able to have all these slides because I know we gave you a lot to think about in an hour. We gave you four years of long division in 1 hour. So that means life really is too short for long division.
We will also be sending out the recording to everyone, and it will be available on YouTube. Thank you, everyone, and have a great day.
Thanks, everybody. Bye-bye.
Thank you, everyone. Bye.